Okay, we're looking at set 2 now, networks, definitions and graphs. So a network is formed by objects which are in some way connected. So we've got 4 examples that we talked about in the introductory video. We've got a road network, so we might have a network and we can join interconnecting corners of streets, for example. We might have a computer network where we can draw between the central network and individual computers a network. They're connected, and so on. We could also look at a rail network. We can look here from one spot to the next stop, to the next stop, and how they are connected. And we can draw these in a network graph. And of course, a social network. You could look at yourself in the middle, and you can see the connections between you and your friends, but then say your best friend might also have some connections between some other people. So we're going to be drawing some networks. If you haven't seen this before, on the right there are some, is an example of a graph network. There's some things on the graph, some definitions that we need to learn about. And so let's have a look at these. These little points here we call vertices or nodes. The connections between these vertices, so from A to B, from B to C, from A to D, from B to D, D to C, D to E, and E to C, are all called edges. So the set of points are vertices, or vertex, if they're talking about one, and then all the lines that join those vertices together are called edges. These edges show the relationship between two of these points. If an edge connects to a vertex and back again, called a loop, that's a new term that we're going to introduce to you. So an edge which connects a vertex to itself is known as a loop. The degree of a vertex is the number of edges that lead to and from it. So for example, if we have a look at D, 1, 2, 3, 4 edges, so the degree of vertex D is 4. If we have a look at vertex B, 1, 2, 3, the degree of vertex B is 3. So if we have a loop, how do we talk about that? So it's still all the lines coming off at 1, 2. So if you have a loop, you actually add 2 edges. So 2, 3, 4, 5. So C would have a degree of 5. An area that is bound by edges is called a face. The area outside a network is also considered a face. And let me rub all of this off. So this space in here, that's one face. In here, it's a second face. In here is a third face, and then all this outside area is a fourth face, and then within that loop is a fifth face. So that would be 5. A planar network is one which can be drawn without edges crossing over. In a non-planar network, edges cross over without intersecting at a vertex. So let's have a look at this planar one here. None of these edges, if you were to draw over them, cross over. They go straight from point to point. So that's considered planar. But if we have a look here, if we go down from the top to the bottom here, that is crossed by that one and also by that line. So it's considered to be non-planar. A simple network has no loops, and it also satisfies a condition that each pair of vertices is connected by at the most one edge. So if we have a look here, here's our vertices. We've got two pairs here, 1, 2. There's one line, so one edge that fits with that, and then there are no loops like this one here. So if you go to each of the points, it's only got one line from here to here, one line, from here to here, one line. So that's why it's called a simple network. We were asked if this is a simple network. It has a loop. So straight away it's non-simple. I don't have to worry about anything else unless there's a further question. If we have a look at this one, there are no loops, but let's have a look and see if each pair of vertices is connected by at the most one edge. So here's true, here's true, here's true. But if we have a look at this vertex from here to here, there's 1, 2 edges. So that's why that becomes non-simple. A connected network is one in which it is possible to travel from every vertex to any other vertex by means of all the edges. So if I start here, I can go around and I can get to all the other vertexes. If I have a look here, I can't. There's no line joining. So that one would be disconnected, whereas this one is connected. If I start here and go around and I want to, oops, can't jump. So that is disconnected as well. Other ways that we can have a look at some graphs is we can look at whether they are directed. Okay, and so we can tell if they're a directed network because they might have an arrow on them. So if we have a look at this example of an organisation, you've got your president up the top, they make the final decision, and then they will send that down to the vice president, secretary and treasurer, or down to the members, or it might go through the vice president down to the members in that way, or to the secretary. Instead of being called an edge when it's directed, we now call it an arc. And in some books it might be written as a diagraph, but we tend to use the word directed in all of the questions that you have. If an edge has no arrows, like this one down here, we assume that it's two-way. So you can go from West End to the town of Blackstone and back again. Sometimes we will add weights to our edges to give us a sense of distance to that spot. So from West End to Blackstone, it's say 41 kilometres, or it could be in fact 41-minute drive. See what the question is implying. In this case, it's a distance. So from Port Evans, it's 30 kilometres to Summerhill. Let's have a go through some questions on page 13. Okay, volume 2.1 there. I'll just change my pen. So for the graph shown, state the number of edges. So the edges are the lines between two vertices. So you could, and I suggest using a highlighter for all of these, you could do something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, and so a number of edges is 11. The number of vertices, so remember the vertices are our little dot points, so you could count them: 1, 2, 3, 4, 5, 6, 7. The reason why I'm writing them down so I know that I've counted it. The number of faces. Okay, so the faces is the area. So you could choose another highlighter now. So you could go 1, 2, 3, 4, 5, and don't forget there's another one outside. +1 makes 6. The degree of vertex A. So that means how many lines are coming, how many edges are coming off vertex A. So 1, 2, 3. The degree of vertex B, 1, 2, and now it's a loop, we add 3, 4. So there's actually an extra one with a loop. What I would like you to do now is go to page 40 and do question 1 and question 2.